Welcome to Brunda Engineering Academy. In this video, we learn about a concept, an important concept is that it is very important for balancing of the forces. Balancing of the forces, it is a very important concept, that is equilibrium. To understand the equilibrium, or what is the to know about equilibrium, first of all, I am considering a body. Suppose it is a body. Now I am applying number of forces on this body in different directions. In this direction, and here in this direction, or whatever it may be, in a different directions, I am applying the forces on the body. Is in engineering mechanics point of view, if we apply the number of forces acting on a body, if the number of forces acting on a body, then there is no change in its position. Then there is no change in its position. If you apply the number of forces, if you apply the number of forces acting on the body, if you apply the number of forces on the body, even then there is no change in its position. That means there is no movement in the body. Then that body is said to be in the equilibrium condition. Then that body is said to be in the equilibrium condition. If number of forces acting on the body, then there is no change in its position. That condition is called as the equilibrium condition for that body. In the engineering mechanics point of view, the equilibrium having three different conditions. One is algebraic sum of the horizontal component will be equal to 0. Algebraic sum of the horizontal component will be equal to 0. Suppose here F1, it is F2, it is F3, and here it is the force F4, it is the force F5. 5 forces are there. Next, sigma h equal to 0 means algebraic sum of the horizontal components. What are the horizontal components? F1, F2, F3. These are the horizontal components. That algebraic sum of the horizontal component equal to 0. Next, second condition for this is for the equilibrium is sigma v equal to 0. That means algebraic sum of the vertical components means vertical forces. What are the vertical forces? F5, F4. These are the vertical forces. Okay, that algebraic sum of the vertical forces will be equal to 0. Next, the third condition is sigma m equal to 0. That means algebraic sum of the moments. Algebraic sum of the moments will be equal to 0. Moment is nothing but the force into perpendicular distance. Moment is nothing but the force into perpendicular distance. So these are the three conditions for the equilibrium. Okay, equilibrium means number of forces acting on the body, then there is no change in its position, then that body is said to be in the equilibrium condition. The conditions of equilibrium are three conditions. One is algebraic sum of the horizontal components, that is sigma h equal to 0. Algebraic sum of the vertical components, sigma v equal to 0. Algebraic sum of the moments equal to 0. So while solving the problem, suppose a practical example I am considering, a practical example. Suppose in a coordinate system, suppose it is the coordinate system. Now I am applying the force, of 5 newtons at this location, and this is the origin. Now here I am applying 10 newtons of force, and another force, that is 20 newtons of force. Like this I am applying, and here 30 newtons of force, and here I am applying a 50 newtons of force. Now if you observe this diagram, there are totally 5 forces are there. First, coming to the right side, 5 newtons, 10 newtons, 20 newtons, 30 newtons, 50 newtons. 5 newtons is clearly horizontal component. Okay, in this video, I am explaining about the what are horizontal, what are vertical, how can you resolve that vertical and horizontal. Now, 5 newtons is the purely horizontal, whereas 10 newtons, it makes some angle of inclination with the horizontal, that is theta. That is theta. Next, assume. Okay, next 20 newtons. 20 newtons force can be angle of inclination with the horizontal can be assumed as the alpha. Next 30 newtons of force. Next 50 newtons of force. Now to solve this type of, I want to calculate the magnitude of the resultant force for this problem. Magnitude and direction. Magnitude and direction. Suppose it may be taken as not not theta. Why? Because there is a confusion may be occur. So that's why I am taking that as a beta angle. Now I want to calculate the value of magnitude and direction of this type of system of forces. If you observe this diagram, number of forces acting in the system. So how can you proceed? For that, we have to consider sigma or that resultant force R can be written as R equal to square root of sigma h square plus sigma v square. That means horizontal component, algebraic sum of the horizontal component square plus algebraic sum of the vertical component square. Next, theta equal to tan inverse of sigma v by sigma h, tan inverse of sigma v by sigma h. So you have to calculate in this way. So for that, first of all, you have to identify the value of sigma h. Means algebraic sum of the horizontal components you have to calculate. How can you calculate horizontal component? For that horizontal component, how can you calculate? Suppose in this type of problems, first you remember the forces are acting in the right side or left side. Right side. If the forces are acting towards right hand direction, you take it as positive side. If the forces are acting in the left hand direction, you take it as negative. 5 newtons. 5 newtons is the angle of inclination. That is right hand direction. So 5. So positive sign. Next, coming to the force 10 newtons. 10 is the inclined force. We are calculating the horizontal component. What is the horizontal component? In the previous videos, we explained about the composition and resolution of forces. Okay, then it can be written as 10 cos beta. 10 cos beta. You can write that. Now, the deciding factor is the sign conversion. The 10 newtons will be acting in the right side direction. So, keep that as plus 10. Next, 20 newtons. 20 newtons force is clearly acting in the left hand direction. So you can take it the sign as minus. So 20 cos sine alpha. 20 cos sine alpha. Next, 30 newtons. 30 newtons will be the left hand side. So 30 newtons. And 50 newtons. 50 newtons is the clearly vertical direction. So you can neglect that vertical component while calculating the value of sigma h. Next, coming to the sigma v, means algebraic sum of the vertical components. Vertical components means vertical direction means either the force in the upward direction or in the downward direction. Upward direction, if the force is upward direction, you can take it as the positive sign. Whereas if the force is acting in the downward direction, you can take it as the negative sign. So first coming to the starting from the first force, 5 Newton. 5 Newton is the clearly horizontal force, but you calculating vertical components, algebraic sum of the vertical components. So you can neglect that term. So then next coming to the 10 Newton's force. 10 Newton's force that will be acting in the upward direction. upward direction. So you can take it as plus 10. 10 sine beta. 10 sine beta. Next, coming to the 20 newtons. 20 newtons will be acting in the upward direction. So you can take it as the positive sign. So 20 sine alpha. Next, coming to the 30 newtons. 30 newtons is the left hand direction, that is clearly horizontal. So horizontal means that will be the 0. Next, 50 newtons. 50 newtons will be acting in the clearly downward direction. Downward direction means you can take this as the negative. So minus sign you can take. So minus 50 newtons. So in this way, we can calculate the value of sigma h and sigma v. If you in the realistic problems, they may give the value of alpha and beta. Then you can simplify some value, sigma h value you get and sigma value we get. Then you can simply substitute that values in the resultant formula r equal to sigma square root of sigma h square plus sigma v square. Whereas the direction of the resultant force can be calculated by using this relation, theta equal to tan inverse of sigma v by sigma h. So this is about the complete information about the equilibrium condition and what are the important conditions for the equilibrium, and a small example to calculate the resultant and the direction if number of forces acting on the system. In the next video, let us solve a problem belongs to the number of forces acting on the system. Okay. So please subscribe Brunda Academy channel. Thank you.